It's science time in 8th grade science. Today is October 14th, and we're exploring friction. The first thing says, these students are demonstrating a floating rice flask trick. One student is able to lift the flask filled with rice by inserting a chopstick into it. When the other student tries, the chopstick slides out and leaves the flask on the table. See whether you can figure out the forces involved in this mysterious phenomenon. So now we're going to play a little video.
Both of these flasks are filled with rice. Notice what happens when the students each push a wooden stick into each flask and then try to lift the stick out of the flask.
Oh snap. Okay, so what's going on? Do you have ideas?
No.
Well, I do have something to
Cool,
say.
let's hear.
So, why were they packing it in instead of just pouring it in? If you see what
Okay,
I'm
so you
saying.
think maybe there's something to that, right? Maybe
Exactly.
you think on one of them the rice was packed in, on the other one it was just
Well,
poured
it seemed. Well, in the very beginning, the girl was like packing it down. Maybe that.
in. Okay,
messed
good,
something
good
up.
thought. Cyrus?
Either that or in the boys, there is glue. Like they literally carefully. Because it looked like he was doing something.
So one thing we can tell, there is evidence suggests that there is some difference between these, right?
Yes.
Do you have any other ideas, Rhett?
Is your computer supposed to be showing the whole screen?
It is.
You can only see half the video.
Yeah.
Oh, well no, that's okay. This it shows up on the, this all is part of the video. This is just a little bubble so that they can see me. Thank you though, Rhett. There you go.
Yeah, he's dead like that.
Maybe we'll never find out. Alright, friction.
No, that's not.
The key to this trick is friction. So you should write this down, please. Friction is a contact force, and we did talk a little about friction already, I believe. But in friction, the objects must be touching. That's why it's called a contact force. And then Colton was getting at this. I didn't want to give it away, but it says the flask that cannot be picked up is loosely filled with rice. The flask that is picked up is tightly packed with rice. So, like I said, Colton, you had it backwards, I think, but it was almost right? It was tightly packed. So what's the difference then between the tightly packed and loose? Why does that make enough of a difference that the chopstick will hold the flask up? What do you think, Justice?
Because if it's tightly packed, then friction is going to act upon when you lift it up.
Yeah, but why? You're right. There's more friction. That's the point, but why?
It's squeezing the chopstick.
Yeah, do you, I don't know, can I press this notes thing? Oh, that's not what I wanted. I was going to write on this, but I just won't this time. But you remember, we talked about the two things, this was a while ago, we talked about the two things that increase friction, right? It's basically how smooth or rough the surfaces is. You should write this down. The two things that affect friction are how smooth or rough the surfaces is, and the force pushing them together. So the how smooth or rough the surfaces are, and the force pushing them together. If we make the surfaces smoother, does that increase or decrease friction?
Increase.
If we make them smoother, it makes friction more.
Increase.
Yes. If we make them smoother, it makes less friction, right? What's something we commonly do to make the surfaces be smoother?
Wax the floors.
Okay, yeah, waxing the floors is not, we don't do that to make there be less friction, but when the floors are waxed, there's less friction, and so it's easier to slide around. What else do we do commonly to reduce
I was just
friction?
gonna ask, what could you say it again? Because I got to like the two things. I can't talk. Like how smooth or rough they are.
And the force pushing them together. So how smooth or rough it is, and the force pushing them together.
So like if an object has less weight, has less friction.
Yeah, and it's not the weight, it's the normal force. So remember, we talked about the normal force, but the normal force is what is the force exerted by a surface that holds up an object. So the greater the normal force, the greater the friction, and the rougher the surfaces that are in contact, the greater the friction.
Yeah.
The tightly packed rice creates more friction than when the chopstick is inserted. This friction between the rice and chopstick allows the plastic to lift it. Try it for yourself, but try it a different time. If you've ever tried to push a heavy box across a rough floor, you've experienced friction. Friction is the resistance you feel when you try to push the box. If the box were empty, there would be less friction, and you could more easily push the box, right? Because there would be less normal force. If the floor were smooth, there would be less friction, and you could more easily push the box. It says, 2 similar-sized friends encounter a long hallway with a smooth tiled floor. One girl is barefoot, and the other is wearing socks. Apply what you already know about friction to predict which girl would slide farther down the hallway. So the choices are, the girl with socks will slide the farthest, or the girl with bare feet will slide the farthest. If you vote for A, please raise your hand. Okay, that's everyone, so we'll just select it. Check.
That hurt doing
Nice,
this.
well done. The girl who has less friction with the floor will slide farther. So why do the socks have less friction?
I don't have that.
They're smoother. They're smoother. What's up, Leo?
And say they're smoother, and with your feet that might hurt because for some people feet's kind of rough at the bottom. It'll just
Right. It might even make it so that the force we applied that we would want it to slide with makes us fall over good.
I don't have
It
that
says,
box.
that's okay, don't worry about it. It says, is it smooth or rough? The surface of any object, just move on. The surface of any object, including paper, is uneven. Look at the magnification of each object and think of how the surface would feel. So we've got little bullet points here. This is the surface of the metal ruler. Can you guys put this on your little computers and see that too?
Yeah.
Where?
So is this smooth? It might have looked smooth in the big picture, but does it look smooth when we look at it like that? No, we can see there's little ridges on it, right? You can see the little lines that represent ridges. What about the brick? Well, that doesn't even look smooth in the picture, but it certainly looks rough when we magnify it. The wood, once again, very rough when we magnify it. And the paper, even though it feels smooth when we touch it with our hands, there's still little imperfections in it that make it rough. Right? And the rougher the surface, the more the friction, right? The rougher the surface, the more the friction. So this is a little model of a finger interacting with the surface of wood. So what do these little lumps, the finger's the top one, what do the lumps represent on the finger?
Fingerprints.
Yeah, your fingerprints, the little ridges in your skin, which your skin has all over it. It's not just fingerprints. And the surface of wood is rough, and so it has those jagged edges. What, and this is getting a little bit ahead of ourselves, but what, could we put something in between these to make it smooth out the cracks?
Probably.
What?
Toothpaste.
Toothpaste is an odd thing to choose, but what do we commonly use to reduce friction between objects?
You sand it off.
Okay, we could sand it. We could make the surface smoother. But we'll talk about it later. But we could. There's some substances that we can put in between that we just coat them with to make it smoother, right? And we have that's a certain class of substances we'll talk about later. It says, examine the model showing the interaction between the surface of a finger and the surface of the wood. Friction is created when the hills and valleys of one surface stick to the ridges and valleys of another surface. Choose one of the other surfaces above. That's the little drawing from way up here. And you'll do this on your own. Because we're doing a video, I'm going to pass over this, but that will be part of your homework. This says the effect of surface variation or friction. The friction between two objects depends on several factors. One of the factors is how smooth or rough. We already said that. A smooth surface creates less friction than a rough surface. And then moving on, it says the microscopic hills and valleys of the rough surface are more likely to catch on the opposing hills and valleys. So if we think about it, like just looking at this picture up here, we can tell even if we had objects that were just shaped like this, they wouldn't go smoothly over each other because the hills and valleys would crash into each other. Basically, that's what's happening when there's friction at every single object. We're going to move over to the lab for now. We'll do that later. Friction opposes motion. Did you write that down already? Friction opposes motion. Please stop going back where I told you not to. Friction opposes motion. When we do the lab, it'll show that the friction changes between different surfaces. So how can we reduce friction, right? Friction is a force that opposes motion. If we want the motion to continue, there's one word I'm looking for. What? What do we do to reduce friction? You know this about like machines, or what do you put in machines to make the surfaces not rubbing? Oil, which is a lubricant. So please write that down. A lubricant is a substance that reduces friction.
Is it what?
A lubricant is a substance that reduces friction. It says if your bike is difficult to pedal, too much friction between the chain and the gears might be the cause. One way to reduce the friction is by adding a lubricant to one or both surfaces. So basically, if we think about that drawing that was up there again, what a lubricant does is it fills in the cracks to make both surfaces like they're smooth. Does that make sense?
Yes, sir.
Why would we want to use something like oil as a lubricant and not water would do it, right? Our water would fill in the cracks, but what's water also going to do?
Make it
I know, but
rust.
Could make it rusty. What else?
It'll heat. Friction will make stuff hot.
Okay. Yeah, friction does make stuff hot. And we're going to get to that in a second. But and you're saying that maybe the water would boil away or something where the oil may not?
Yeah.
Probably, yeah, the oil's a thicker substance.
The oil's a thicker substance. That's kind of what I was looking for. The oil's a thicker substance. It's got a lower viscosity, right? Or it's got a higher viscosity. It resists flow more. And so it'll just stay in the crack instead of getting out of them when it moves. It says you can also reduce friction by replacing sliding friction with rolling friction. So basically you can use wheels on an object to make it move more easily. The reason rolling friction is less or commonly less than sliding friction is because if we think about it, when something rolls, a different part of that object is touching all the time, right? So it's a different surface every time. And so it's going into the gaps differently instead of just sliding past. We can also increase friction by making what? Well, if we decrease friction by filling in the gaps, what could we do to increase friction?
Make things
Make
rough.
Yeah, make them rougher. Why would we want to increase friction ever?
Like maybe climbing or.
Yeah, this guy's climbing a rock. He does not want to slide off the rock. Why else? I know there's a thing that Mr. Berry uses in football where you jump up onto an inclined surface and that's like got sandpaper on it so that you stick when you land, right? Speaking of sandpaper, sometimes, you said earlier that sandpaper, we can sand something to make it smoother, but sometimes we sand things to make them rougher. Why would we want it to be rough by sanding it? Yeah.
Well, as you just said, maybe to stick and like make it tougher, rougher, so that
Right.
friction
So
acts
stuff
on.
doesn't move as much.
Right. So like if we were thinking about, like for instance, painting, we want there to be rough surfaces for the paint to get into so the paint will stick on it, right? If you try to paint a smooth surface, the paint will just slide off,
Yeah.
right? So we can increase friction by making the surfaces rougher. Okay, your assignment, there's an evaluate section here. Your assignment is to finish that draw box that we passed over at the top and to finish this evaluate section.
Got you, fat.
Questions? Do you have questions about friction before I end the video and we move on? Okay.